After statical analysis, connection design. In MkaPHP, you can perform connection design without using any third-party software. Some of connections made by the program by automatically. However, some of the connection needs user's attention. Let's explore the connection design in MkaPHP. For time saving, I have already created a model and named it Connection Design. It's a standard truss model with a mezzanine. To perform connection design, you have to be finished the statical analysis. Let's make the statical analysis. I click Statical Analysis button and click Run button. Remember that to make the statical analysis, you have to define sections and loads. Program finished the statical analysis. Please be sure that your all sections is sufficient according to the code. To make the connection design, you need to click After Statical Analysis tab. Then you need to click Connection Analyzer button. I click it. The connection design menu welcomes us. First of all, you need to select the reference axis. The two axes available. One is axis 0 and 1. The other one is axis 2 and 3. It differs from the mezzanine. I select the first. Program lists several connections here. You can select the connection with click on it, or simply you can click on the picture. Then the program automatically select the relevant connection. This is the node number. The site indicates where the loads come from. This is the image. And this is the connection ratio. If input check available, program checks the inputs. Then you can change the connection. Click the edit button. Let's look at this halonge connection first. Let's click the edit button. Remember that the ratio is 1.5. I click the edit button. So here the detailed connection window. It's the 3D view. And these the parameters. It's the members. It's the plate. It's the haunch. And of course it's the weld thicknesses. Let's check the members. This is the primary member. And this is the secondaries. But in this time, we don't have secondaries because it's one-sided connection. So the primary section is here. Let's edit the plate. You can edit the plate width here, height here, and thickness here. Hashover here. And bolt information here. Draw 3D, this menu. Draw 2D, this view. And input warnings, you can see this button. There is one input warning, as you see. And the calculation is here. The results in this tab. As you can see, our moment resistance is not sufficient. We need to edit the connection. You can see a detailed report here, of course. Let's increase the connection's moment capacity. I increase the thickness. Program immediately calculates again. You can see this in the calculation tab and the result tab. So, as you can see, our moment resistance is sufficient now. This connection is okay. But we don't save it. Let's click it again and make it 20 and check the results, and it's done. Of course, you can change other parameters. You can placing bolt molecule or up to down, down to up. If there is a row exists in the upper flange, you need to click here. You can see the pictures changing. If any row exists below lower flange, you can click here. Then the picture changes again. Number of rows inside the flange. 1, 2, 3, 4, 5 here. And the bolt standard here. So the bolt grade and the bolt diameter here. So you can change the bolt locations this manner. It's very clear because of the picture. You can change the haunch, of course. This is the haunch height and this is the haunch length. You can change these parameters, or you can select non-haunch, or you can erase the haunch. You can change the weld thicknesses here. The picture indicates the weld's place. When you finish the design, you can save these parameters to use another connection. I click Save button. Then the program automatically saves our connection. I click OK. I close this connection. I click Yes. As you can see, our ratio is updated. Then this is the right side. Of course, you can change the connection type. Bolted, welded, cranked are available. Let's click bolted again and click Edit button. These are the same connections, so I want to use the other connections attributes. To do this, you need to click Open button and select the relevant file. Then press OK. Let's check the plate thickness. I click it. As you can see, it's changed to 20. Let's check the calculations and results. It's the same. I close here. And of course, I save this. And this is okay also. Now, let's design this foundation. I click Edit button. Again, members, welds, path finding, soil information, the base plate, and the flange info is available. Let's check the calculations first. Let's check the results. Our base plate thickness is insufficient, and also our longitudinal and the traverse reinforcement are insufficient. Let's change this parameter to make the connection sufficient. I click the Draw 3D again and click the Members tab. I click the Plate tab. The plate thickness is 10 mm. It's slightly low. Let's increase it. And let's check the calculations again. Our plate thickness is sufficient now. We need to increase the reinforcements. Click the Draw 3D again and click Path Finding tab. This is the geometry. This is the concrete grade and ground grade. This is the dimensions. The figure shows which dimensions change where. And this is the footing reinforcement. Let's increase the count. And this one. And check the calculations again. Again, insufficient. Let's go Draw 3D. Let's increase the diameter. And check the calculations again. Now our connection is sufficient. Let's see the report. The detailed report here. Let's go to the Draw 3D again. You can change the column reinforcement here. And of course, welds and flange plates here. You can change the flange plate type. Let's save the connections parameters. I click Save button. This is saved. I click OK. And I close it. Yes. Then edit this one. The right one. I click Edit button. I load the default parameters. This is the base plate. I click it. And I click Open. Let's check the calculations. And it's sufficient. It's good. I close here. I close yes. And also this one. Again, I load the parameters. Let's check the calculation. It's okay. I close here. And this one. Let's check the calculations. It's okay. And the last one. Check the calculations. It's okay. Now our all connection is sufficient in this axis. Of course, you can check the other axis. Let's apply the attributes disconnection. This time it's insufficient. We need to edit this connection. Let's click Edit. Save the calculations. Bolt tensile design not sufficient. Let's fix it. We need to change the anchor type. Let's see the calculations. And it's sufficient now. And again this one. the base plate, thickness and the reinforcements are insufficient. Let's fix it. Let's check the calculations again. And the bolt tensile is insufficient. Let's fix it. Change the anchor type. And see the calculations. Now it's okay. Let's click edit. Let's click plate. Click retro view. Change the bolts. Change the plate's dimensions. And it's okay. I save it. And I check the calculations. It's okay. Now loading the attributes. And that's it. It's very easy to make connection design in MkaPHP. See you next lesson.